Welcome back to linear regression series using the Possum dataset. In the previous steps, we built a simple linear regression model to examine the relationship between head length and total length. Now we will explore the regression results using the summary function. The summary output gives us several important pieces of information. Let's break down and understand what each component tells us. Residuals are the differences between observed values and the predicted values by the model. A good model will have residuals centered around zero with a symmetric distribution. This section includes the estimated coefficients for the intercept and the predictor variable total length. The estimate tells us the average change in head length for 1 unit increase in total length. Standard error is the error of the estimate that indicates the uncertainty of the coefficient. T-value is the test statistics for the hypothesis test that the coefficient equals 0. Probability column is the p-value. A small p-value, typically less than 0.05, indicates the coefficient is statistically significant. The coefficients represent the estimated value of the intercept and the slope in the linear regression equation, which takes the form head length equals to intercept plus slope times total length. In our case, intercept equals to 42.71 means that in theoretical sense, when total length is 0, head length is 42.71 centimeter. Slope equals to 0.573 means that for each additional centimeter of total length, head length increases by 0.573 centimeter. This is the key value in our model, representing the strength of the relationship between total length and head length. This large t value here indicates that the intercept is significantly different from 0. The extremely small p value confirms strong statistical evidence to reject the null hypothesis that the intercept is 0. Practically, this means that even when total length is 0, the head length is significantly non-zero. Same like the previous value, this high t value suggests that the coefficient for total length is highly significant. The p-value being far below 0.001 indicates overwhelming evidence against the null hypothesis, that is, the slope is 0. This confirms a statistically significant relationship between total length and head length, which means that changes in total length significantly predicts changes in head length. In the regression output, asterisks next to the p-values are used as significance codes to indicate the strength of statistical evidence against the null hypothesis. These symbols offer a quick way to interpret the relevance of each coefficient. 3 asterisks represent high statistical significance with a p-value less than 0.001. This means that there is extremely strong evidence that the variable has an effect on the response. 2 asterisks indicate very significant results with a p-value less than 0.01, providing strong evidence that the predictor is associated with the outcome. 1 asterisk shows the predictor is statistically significant at the conventional 5% level, means p-value less than 0.05, which is widely accepted in applied research. A dot signifies marginal significance with a p-value less than 0.1, implying some weak evidence that the variable may be related to the response. No symbol or blank means the variable is not statistically significant with a p-value greater than 0.1, suggesting insufficient evidence to support an effect. These codes help quickly assess which predictors in the model are likely contributing meaningfully to explaining the variation in the dependent variable. This is the standard deviation of the residuals. Lower RSE means better model fit. In our model, the RSE is 2.595, which means that the typical prediction error in the head length is about 2.6 centimeter. Multiple R squared here indicates the proportion of variance in the response variable explained by the predictor. Here R square 0.478 means 47.8% of the variation in the head length is explained by the total length. Adjusted R square is similar to R square but adjusted for the number of predictors. It penalizes model complexity. Since we only have one predictor, adjusted R square 0.4725 confirms a moderately strong linear relationship. F statistics tests whether the model explains a significant amount of variance in the response variable. A high F value and a low P value indicate that the model fits the data better than a model with no predictors. In conclusion, the regression results show a strong, statistically significant linear relationship between total length and head length in possums. This model provides a useful predictive framework, but we should also consider diagnostic plots to validate assumptions. That's all for this video. Thanks for watching and see you in the next video.